takeaways I like about DesignCon is it's a great industry conference. You really learn what other companies are doing in terms of what are the challenges for their engineers, what are the signal integrity challenges, the power integrity, and what technologies are exciting and new in terms of the 100 gigabit or 400 gigabit Ethernet and the PAM4 multi-level signaling. But I think the one I like is the fact that this is really an industry sort of led conference, and I also am involved with some of the IEEE conferences, and I find that they make a very good balance, because here I can write a very long paper saying everything I did and how I did it, and then I take a lot of times I take a DesignCon paper and bring it down to a very focused and results-oriented paper for IEEE. Obviously, the best part about DesignCon is if you have a conference where you're involved with a lot of your colleagues and you're writing papers, it builds on that interaction and networking. So I would say just the opportunity to network with the industry and my coworkers from around the world. So what happens at DesignCon? Well, there's a lot of different events. There's tutorial sessions on Tuesday, then on Wednesdays and Thursday we have parallel tracks of different papers. We have 14 different tracks, different topics of signal integrity and power integrity and printed circuit board design, chip design. We have the vendor expo where all of the different vendors and industry people can come in and display their products and interact with the attendees. And then we also have our keynote addresses, which are exciting. Today we had one from Microsoft on Internet of Things, and very exciting to see what our future's going to be. The emerging trends that I'm interested in are things like using a pulse response to really understand what's happening in to the signal integrity of your channel. As always with DesignCon here, even in 2017, we still see a ton of interest in how to do fixture removal, the methods, and so I'm very active in a lot of the new standards, IEEE P370, they're working on that. And then finally, power integrity. It's making a big, presentation this year as usual. But what's interesting is power integrity is where signal integrity was probably 10, 15 years ago. They're starting to realize the benefit of frequency domain analysis and impedance and S-parameter behavioral models and some of that type of analysis. So looking forward, I'm finding power integrity to be very challenging and exciting to work on. This year I was very pleased to be able to work with two other companies, Wild River Technologies and Xilinx, and we teamed together, and it was a great tutorial that we put on designing a high-speed SerDes link up to, say, 28 gigabits per second or 56 gigabits signaling. But the neat part about it was as we stepped through what an engineer might do in terms of designing a channel, and we actually broke things down into pathologies in terms of your signal integrity, looking at what was causing the degradation, and this sort of design of experiments looking at what different pathologies are causing loss. And we actually used the pulse response to do this analysis. And then we did simulations, and it talked about the IBIS AMI models that enable us to use these very complex equalizations in the transmitter and receiver and run simulations and predict what we're going to see in the measurements. And then with the final results, we were able to kind of quantify what the difference between material losses versus reflections and crosstalk. So it was a very exciting tutorial to team up with. Well, we used to talk about 5 gigabits and 10 gigabits as being crazy high-speed signaling that was going to be very tough to do, and nowadays everybody just expects it. And we've moved on, and we're in the 40 and 100 gigabits and things like that. So I think the message is what seems so tough and challenging today, a couple years from now, it's probably going to seem the normal and expected designs. I actually have solved a lot of problems and troubleshooted a lot of bad designs, and what it comes down to is quoting one of our experts in the field, Bruce Archambault, ground is for potatoes and carrots. In electrical circuits, we got to pay attention to return currents and the return path, and that's pretty much what a lot of the signal integrity and even power integrity problems are. It's those parasitics and how the ground currents are returning. The IEEE P370 group just met last night, and we had a great meeting. It's actually very impressive to see with just a little over a year's time, we already have a really good draft that's going to be published in the next few months here, and should be available if people really want to take a first look at this preliminary draft. But more exciting for me as an engineer, and something if you really want to get involved, we actually have 3 projects. One is a simulation library. We've simulated a whole bunch of different PCB structures, and you can practice on your own doing fixture de-embedding with these simulated structures. We also have a plug-and-play set of actual physical boards where you can practice taking measurements and doing fixture removal. And then third, we have a project where we now have a software MATLAB program that will do an S-parameter quality check and see what how good are your S parameters after this fixture de-embedding. So as you go up in frequency and high speeds, you have to deal with classic transmission line issues and reflections and crosstalk, and when you go to take a measurement, you actually have to connect somehow, and those probe leads are going to impact your measurement, and so there's a lot of measurement instruments are constantly trying to figure out how they remove the effects of probes and connections. So, that's a problem with measurements. And then on the simulation side, of course, you're using models that make certain assumptions, and you don't, there's always a question whether it's really has the correct as fabricated inputs to your simulations. But I think the best quote I like there is, and it was a twist on something that Einstein said, was everybody believes the measurements except for the engineer that made the measurements. And nobody believes simulations except for the engineer who did the simulations. So it's a very acute, and to be a good engineer actually, and that's where I really try to emphasize is you need both measurements and simulation. And using the two together is really where you gain a lot of insight and confidence in your engineering designs. I work in the simulation department of Keysight with our ESOF EDA tools, and specifically we have an advanced design system. It's an electrical engineering environment where you can do schematic capture, data analysis, and even layout design. But what's very exciting is we have this new tool. It's got a great user interface so that it enables a lot of your average engineers to jump into and start doing EM simulation. So it pulls in full multi-layer high-speed digital board designs, and you can select nets. It automatically places ports and lets you do signal integrity simulations. You can also do it for power integrity and look at your power rails, look at IR drop. So and that's another benefit. It brings signal integrity and power integrity into one same user interface for doing EM simulations. Again, I think it goes back to one of the earlier questions in terms of what's very important for signal integrity and power integrity, and designers should always keep in mind of where are those return currents. Ground on a schematic is often neglected as a simple little symbol somewhere and left to the layout designer to figure out how they want to connect it. But you really do need to pay attention to how ground and those return currents are flowing. And another thing along those same lines of recommendations is Lee Ritchie's another expert in the SI world, and I love in one of his books, Get It Right the First Time, he really emphasizes how you should classify your nets and prioritize them so the layout designer knows what's important and what should be routed first. I love DesignCon. This is my basically 11th year probably, and I've been on the test and measurement track as co-chair with Al Neves of Wild River for 10 years now, and it's been a great experience. I have a lot of great friends and people I look forward to seeing every year, and this year is very special because they nominated me for Engineer of the Year, and today I found out that I'm DesignCon Engineer of the Year. So it's an honor, and I'm actually rather humbled by the fact that I'm going to be doing a panel later today with Eric Bogatin and Michael Steinberger, who are previous winners of the DesignCon of the Engineer. So I have to say that I've attended a few of the sessions, but a lot of them I'm doing myself. So I've been very busy in terms of doing tutorials, presenting in our industry track, also presenting in our test and measurement track, and introducing authors and speakers for the different papers. But I would say, again, the Keynote addresses are always very inspiring, and then from my personal interest, I do like my test and measurement track and the fixture removal type papers. Those are always fascinating to me. It's great to see Sierra circuits at DesignCon again this year. I always look forward to it. Printed circuit boards are one of my favorite things. That's really the glue that brings all of these different transmitters and receivers and memory chips and everything together. And although we keep talking about other ways of connecting devices, printed circuit board technology keeps advancing, keeps rising to the challenges of both power integrity and signal integrity and the creative three-dimensional designs that a lot of the engineers are coming up with these days. So it's a pleasure to have Sierra Circuits here with their printed circuit board technology.